Hello everyone, I'm Brian Kopack from Formtek and welcome to Formtek Talks. In today's podcast, I'm joined by Kevin Enos and Charlie Burgess, and our discussion focuses on straighteners. We get into things like, do you really need one, and how you should size it, and even talk a bit about looping pits. Basically the things you may want to consider when you're making a decision, adding a straightener to your operation. Thanks again for joining us. Okay, welcome to Formtek Talks. My name is Brian Kopack, and I have two guests here today, Mr. Kevin Enos from Formtek Maine and Mr. Charlie Burgess from Formtek. Sorry about that, Charlie.
That's all right.
And today we're going to talk a little bit about straighteners and the nuances of straighteners when it comes to roll forming and how they can be used in your roll forming line. Kevin, I'm going to kind of start with you. Why don't you tell us a little bit about why you want to use a straightener and when it's really not necessary?
Primarily, if it's coming in coiled, you're putting it on a mandrel, you're going to get coil set in that material. So traditionally, you want to have a straightener in as a part of a line to remove coil set. That is all a straightener is designed to remove. If you've got other coil conditions other than coil set, that's going to get you into a leveler. So oil canning, things of that nature are going to be addressed with other pieces of equipment other than a straightener. And those are going to, based on the application, those are going to come in a number of different formats. Those could be 7-roll, 9-roll, 11, all the way up to 21-roll, what we would consider a precision straightener. So some applications are going to require an extra amount of flatness. So a motor stator, for example, has to be completely flat in order for the efficiencies of the motor that's ultimately going to be made from that to be as energy efficient as possible. You can have those in configurations, again, up to a 1/2 inch in thickness, up to 84 inches in width. And if you've got material, again, that's not to cold rolled or mild steel, and you're going to get into more HSLA type materials, you definitely have to have a straightener for that type of an application. That's going to, again, remove the coil set before the material gets introduced to a secondary piece of equipment or a loop. Then you can also have combinations of that as well. So a feeder straightener, a straightener with a pull-through feeder, and different combinations for space-saving purposes would also comprise of a straightener's application.
You were talking about pull-through feeders. There's also pull-through straighteners.
Yes,
that are small devices for usually less wide strip widths. Is that correct?
That's correct. And I apologize. I intended to say not pull-through feeders, but feeders with pull-through straighteners.
Oh, no problem. Tell us a little bit why you would have, or why you would choose a driven straightener over a pull-through straightener. Is it strictly material characteristics, or is there a reason for that?
They're primarily application driven, and I'll say application, but the customer is typically the one specifying that, and it's a combination, what we call a combination unit, a straightener with a pull-through, a feeder with a pull-through straightener, as an example, is usually a space consideration. So that's a customer-driven. In every other respect, a driven straightener is typically always the best way to go because, again, you're going to want to work that material. A pull-through straightener is not going to be effective once you start getting into thicker, heavier gauge materials, wider materials, the friction involved, et cetera. Line speed is going to be a factor in that. You would not want, for example, a pull-through straightener in a surface critical application. Again, the purpose of the feeder is to start and stop. The purpose of a straightener is really you want that going on a continuous basis. With a combination unit, when you're starting and stopping, you have the pull-through straightening rolls in contact with the material at all times. And as a result of that, there's an increased chance you're going to mark or scratch that material.
How do you, like with a pull-through straightener, you have to feed through it at some point in time if you've got, if you're feeding from a coil. So they have a quick open feature and that allows you to get the material through it, and then you close down on it. If it's non-driven, you can't feed through it.
Correct. There's two ways of doing it. One is to have a driven set of pinch rolls on the entry end of the pull-through straightener. The second means is to have the head open that you can get that material through into the feeder pinch rolls.
And then you close it down.
Then you close it and lock it in position.
Is there any kind of calculation, like how much back tension a pull-through is going to give you, so you know how much you got to exert on the exit end to actually get that material to come through it, or is it just kind of a rule of thumb?
It's generally a rule of thumb. I'm sure from an engineering perspective, there is probably a rule to it. I do not know what that rule is.
Yeah. I just was wondering, like for a servo feeder application, you would never want to go with a pull through. I imagine in any application, because you are going to have to pull some kind of tension with that and possibly slip.
Yes, and that goes back to my earlier point about damaging, marring the material, scratching the material as a result of starting and stopping in a pull-through scenario. With a driven scenario, again, even if the material is just creeping along, it is in that creep mode. It is not getting those what's typically a 7-roll configuration. Those 7 rolls are not stopping on that material every time the feeder is starting and stopping for that specific feed progression.
Normally, in a tube mill application, customers won't call the straighteners. They'll call the straightener a flattener, and they're really only flattening the last pieces of the coil or the initial entry section of a coil. So in roll forming, you mentioned we tend to straighten all of the coil, all of the material rolls through the straightener. Why is it that or do you happen to know the reasons for a tube mill why they don't do that? Is it not just important to have the coil set removed in the middle of the coil, but only the ends for shear end welding? Do you have a lot of experience with that?
I do not, although you guys can speak better to the impact on a roll forming. It is my belief, and certainly as a manufacturer on the straightener side of it, that from the beginning of a coil through the end of a coil, it all needs to be straightened or flattened, as some people call it. I would assume in part, when you're first starting a coil, you have where it's been cut, you may have more of a severe downturn to that you have to upturn at the end of the coil as you're bringing that to completion. You're going to have a tighter wrap and a tighter ID in that location. So again, the coil set is going to be greater as you reduce the size of the coil and near the end of it. So hence it's important at the beginning and the end for those reasons, but in most instances it's important all the way throughout. In addition, you'll see changes in the coil from start to finish. It's just the nature of the way the coils are made. So from that perspective, it's definitely beneficial to do it from start to finish. I would think from a roll forming standpoint that the roll forming stations are also working the material to one degree or another. So that may be why there's a difference between a stamping application and a roll forming application.
Yeah, I think with in roll forming, we tend to straighten all the material throughout the coil. I think it's basically more because of the punching, which is similar to a press stamping application. So the punching is very important, and we can't have really coil set affecting where the hole locations are as we're punching. You mentioned leveling, you mentioned straightening. Tell us a little bit about the differences in your mind, what that means.
The easiest way to delineate the two is on a straightener. Most straighteners will have backup rolls. The work rolls are supported by the backups, and they prevent deflection of the work roll. With a leveler, there could be multiple sets of backup rolls, and those backup rolls are intended to induce deflection of the work rolls. And that's why a straightener will only handle and address coil set in a coil versus a leveler's ability to handle many different coil deformations.
Yeah, I remember hearing 6-high,
yes,
and 4-high and 3-high precision levelers, and because that was used a lot in the steel mill applications I had previously.
So to expound upon the difference on those in particular, on a 4-high, it's a non-surface critical application. A 5-high is going to be a topside surface application protection, and a 6-high is protection for surface critical top and bottom.
And I think those are predominantly for flat strip applications where you're not doing any kind of forming. When you introduce like precision levelers, you're basically correcting defects in the strip and then recoiling it. Is that more your application or experience?
No, in our case, they get used in line in production, similar to the straightener, and the final product could be into a press and a die or a shear. It could also be a cut to length line where you're going to be making panels, as an example. And once you get that out of the feeder, you're going to be shearing those into blanks of material. So the flatness is very critical in that instance because it's going to be an end product such as a refrigerator that everybody in the public is seeing.
Mm-hmm. Very true. I know it's not that you can't put a leveler in line for a roll forming system, but it's just not as likely to be seen that way. But there are other choices. You mentioned precision straighteners, which would be, you would have more work rolls to help take some of the coil set out and make the material a little bit more flat. Is there any other feature? Can you put two straighteners in line? Is there any reason to do that, or would you just kind of say if you think you need that kind of work, you would just add more rolls?
I am not familiar with any applications that would have two straighteners in them. I am familiar with applications where we have used a straightener in addition to a feeder with a pull-through straightener. And in that particular application, the material was getting straightened as it came off the reel. The material was then directed upwardly through another turn to take that material from horizontal to vertical. And in that instance, a pull-through straightener was added to the feeder because of the radius in the turn from taking the material from horizontal to vertical position. A secondary pull-through straightener was added there to ensure there was no coil set introduced at the point where we changed planes.
What about if I'm a customer who's running really light gauge materials, 15 thou, 18 thou, 20 thou material? Do I really need a straightener? Or is it, there's really not a lot of coil set because you're so thin and you're bending around that coil that's could be 60-inch diameter or 72-inch diameter. Do you really need a straightener at that point?
My professional opinion on that is yes. Again, nowadays it isn't just a matter of the thickness of material. The yield is a big factor in that, and as you get into the different roll diameters, so the number of rolls is only one factor in that. The roll diameters are another factor. So for thin gauge material, it may actually require more of a precision leveler to better work that thinner gauge material, and the centering of those rolls are another factor in that as well. A couple of other things you get into are roll adjustability. So we have what's called a bank adjust, which is all of the upper level rolls are adjusted as a bank or as one versus individual roll adjustment. So a 7 or a 9 roll straightener, you have the ability to have individual roll adjustment of your top work rolls. In a 19 roll, that is going to be a bank adjust. On a leveler, it's going to be a bank adjust, and that has more to do with the operators, maintenance personnel to a lesser extent. But if you allow an operator to have the ability to individually adjust 19 work rolls, you could end up with all kinds of variations in your product. By having a bank adjust, that ensures that you minimize the amount of individual adjustments that can be made to a machine where you can take it to where you're making scrap as opposed to saving scrap.
Because typically, don't they, I think sometimes they call them clamshell, where you do a lot of work at the beginning. The overlap between top and bottom rolls at the beginning of the process is quite a bit, and then as you progress through the leveler, you throat it open, so that by the time you get to the last roll, it's doing minimal work.
Yeah, although the term clamshell nowadays is more utilized in the cleaning method. So both levelers and straighteners, there is a difference in the ability to clean those machines. And a clamshell is basically like an alligator mouth in that you would open up the front end for ease of cleaning. The other method is you open the entire head front and back, which is what we utilize. And when you have, again, an appliance manufacturer that could be running painted materials or surface critical pre-paint embossed material, then is going to turn around and run galvanized material, you have to have a means to clean those rolls to allow for the changeover in materials.
And what about roll finish? If they've matte chrome, high chrome, how do they determine? I've struggled with that in the past. I typically always just go with high chrome, but I do know that there are options on surface finishes on the rolls.
No, that's a great question. Most of what is sold nowadays is got a chrome finish on it. The biggest advantage to that is it discourages picking up materials, contaminants, and sticking to those rolls and imparting those same materials onto the material. So it's definitely advantageous for the high chrome or chrome finish on a roll to lessen the amount or mitigate the amount of contaminants that may get drug into the roll forming tooling or the press tooling, where serious damage and money expense could be incurred. The other variations have more to do with the pinch rolls as you get into the types of materials on the pinch rolls for the same reason as far as not marking. And typically on a straightener, you're going to have a set of entry and a set of exit pinch rolls. Those are going to be of a different material typically than your work rolls. And it's again because you're gripping and pulling typically on the entry end and then pushing on the exit end differently than you are when you're straightening and working the material.
Interesting. So it's primarily a pickup issue, not so much coefficient of friction issue.
That's
when
correct.
It comes to those type of coatings.
Yes, and again, depending on the material itself. So if it's a surface critical material, at the very minimum, you would have to have chromed rolls as a result. Anything else, the likelihood, again, that you're going to induce contamination is going to have a negative effect on your product.
Another feature that you have on some of your straighteners are what you call an angled head or a perfectly horizontal head. I believe the angled head is mostly if you're going to be looking into a pit type looping pit application. Is that correct?
That is correct. There's a couple of benefits. Again, the vast majority, probably 90% of the straighteners we manufacture are an inclined head. And the advantage there is primarily you are taking material off of a coil. And for this conversation, we'll assume it's a 72-inch coil. The payoff point where that material is coming off to enter into the straightener head, it's advantageous for that incline head as the material with gravity wants to go that direction. As you deplete that coil, it helps maintain that you don't have such a drastic change in direction from that larger coil to a flat head cabinet, where again you may introduce some damage to that material. Faster speeds, if there's a loop that precedes the straightener itself, again to minimize the radius going into that loop, having that the end or the exit side of that straightener in that inclined position negates the potential for reintroducing coil set into that material. You'll typically find them more in higher speed applications than you will a flat type of straightener. The flat type of straightener is, like I said, at this point, less than 10% of the overall market because it's more niche oriented than it is a commodity, if you will, in regards to how it's utilized in the field.
Very interesting. Thank you very much. Another question that I have is right after the straightener, typically we have a looping pit. What if I'm a customer who doesn't want to put a pit in his floor? What alternatives are there in the market? Not necessarily offered by everyone, offered by our company, but what are options in the market that you two have seen?
There's a couple of different thoughts on that. Certainly a pit is best case scenario because it gives you the most excess material, again, for allowing the machinery to operate continuously and not starting and stopping. The feeder is the only thing that's really designed to start and stop on a regular basis. And raising the equipment pass line height can gain you a little bit of additional looping area. Simply stretching out the material, it can help a little bit, but you really don't get any additional feed lengths or additional speed in that configuration. The other concern is, again, the amount of material you have, be it in a pit or in an elongated configuration, that is weight that the feeder is having to pull out of that pit. So by far and away, a in-ground pit is the best way to go. Raising the pass line would be your second best alternative. Your last alternative is stretching out the material or the length of the line, because there's very little to be gained there. There are various types of above ground types of looping. An S loop would be an example where you're bringing that material. This is for thinner gauge, narrow material typically. You're bringing that material out, again, typically with an inclined head on the straightener, into an S loop configuration that goes up vertically, and your exit is of a higher pass line into your next piece of equipment. But that would be the fourth alternative to gaining additional material into a line.
Like an S loop. And earlier we've discussed even possibly vertical accumulators or some type of a strip accumulator as a possibility.
That's correct.
Have you seen a lot of those applications, either of you?
Yeah, I've seen quite a few of the vertical and horizontal. In fact, one of your major product lines in tube mills, I think horizontal accumulators are kind of common, where you have a car that's got a wheel, or I should say an idler wheel on it, that travels horizontally, and as the front end is overfilling it, it's traveling and accumulating all that strip, and then when the process starts back up again, then the car goes back in the other direction and lets material out of it. But vertical accumulators were quite common in one of the industries I was in. But you were looking at a lot of accumulation. They were looking for like 2 minutes of accumulation to do a weld cycle, for instance. You don't really run into that too much in roll forming. Although you do get weld applications in roll forming for tube mills, for instance, and even some of the more traditional lines. But they're usually fairly fast. Your cycle time for the weld's not as much as you would get in a steel mill, where you're trying to weld 46-inch wide material. You're welding 13-inch wide material and 12-inch wide material. Haven't seen a whole lot of verticals or horizontals other than that tube mill application in roll forming. But I know a lot of people don't like pits. And as we talked earlier, we saw a few people that made like the 3-roll verticals, where you just had a single roll that traveled vertically, and you had 2 strands of accumulation, and you could get 25 feet of accumulation.
Which might be all that you need for a roll forming
for
process
roll forming,
with
where
punching.
really all you're trying to do is compensate for feeder at that point in time, cycling. You're not really looking to try and make a weld. And I think it would be something that would be interesting if they could, come up with something economical for that, that single roll vertical and get away from the pits. Just doesn't seem to be a lot out there. We struggled to find what we did find.
Right.
I think it's also a difference, and it could be nomenclature, but an accumulator versus a loop serve 2 different purposes. Typically, the accumulator is to allow a continuous run even when you're processing a changeover. In the case of a looping pit, or vertical or otherwise, it's more a matter of, again, just keeping the machinery going forward on a continuous basis, and not to accumulate enough material that you could continue to run through a coil changeover. So I think there's a big difference, again, as the nomenclature, people use words interchangeably, and I don't think that that's always effective, obviously, on an application basis, where somebody could be asking for an accumulator, but in reality what they really mean is something else.
It's interesting you said that, because when we were looking for those single roll vertical accumulators, what I found out was when I put in vertical accumulator, I got some hits, and then I put in festoon accumulator, and a whole nother selection of equipment came up, and basically the same principle, but they used the shape of the material in that type of accumulator is like a festoon. It just zigzags up and down. And but it's all how people name or what kind of nomenclature they want to use. You really do limit yourself, and you got to use a wide variety of terms if you're trying to find something out there in the marketplace, or you may miss it altogether. I got very few hits on vertical accumulator, but when I put the festoon in, that's where most of those results came that I sent you for that application you had.
And you'll find that's true as we've used it as we're talking, straightener, flattener, leveler. We've used that term interchangeably, but there certainly is a major difference between the straighteners and the levelers and how they're utilized, even the customer base. And that's where the interaction with the customer and understanding the application is very beneficial in determining what actually needs to be quoted for the application.
Well, thank you two very much. On behalf of Charlie and Kevin, my name's Brian Kopack, and I'd like to thank you for tuning in to this week's Formtek Talks, and we'll see you next time. So hopefully our discussion on straighteners was helpful to you. As you can see, there's definitely a number of things to consider in deciding if a straightener is right for your operation, and then which type of straightener is right for you. Of course, please know that we're here to help as you make these evaluations. Please don't hesitate to reach out for a consultation. The best place to do so is through our website at formtekgroup.com, and there's absolutely no obligation. We'd love to understand what you're looking to do and see how we can help you achieve your objectives. For now, thanks again for listening. On behalf of Kevin Enos and Charlie Burgess, I'm Brian Kopack. Join us again for the next episode of Formtek Talks.